Starting from is similar to the homework. So RP equal to 18000 kilometers and RA equal to 8. Everything data new. Okay. So from here, we have to determine the orbit E equal to RA. And A. So from here, this is the electric orbit. So we pick up the Kepler's equation is this, delta T and mu AQ. I would say I will give additional information. So that means here the E can be related to anomaly by tangent. Okay, so because the nu 0, so here we have E0 equal to 0, and then nu equal to mu 0 plus delta nu equal to 60 degrees, so therefore we can determine E, and that one 0.5346 radian. Okay. And I think in my homework problem statement, I simply replaced the whole word by this. Okay, hopefully you know what that means. Okay, so that means here I replace this one. Basically, here I already give to you is this step here. Okay. Okay. Now we have this one, so therefore the right hand side equal to this one. So there delta T. We simply do the calculation quickly. So that will be equal to, let me plug in the numbers for the first time. So 49000 divided by 38398. Again, this is the first time we calculate. So using the radian, the number in terms of the radian in your calculations. Minus E equal to 6327 times sine E. Okay, so again, that is the, later on I won't show the detail, but here just show you, when you calculate E, please, using the value in terms of radian in your calculations. So it will be wise if you can reset your calculators from degree to radian. That'll be good for this class. Okay. So this number will be 3646.8 seconds. About 1 hour. Then the next one. Compared to this one, Okay, so this one is compared to these questions. This is the easy part of the Kepler's problem. This will be the hard one. And this one we're going to use numerical approach. For this one, the same thing. First we calculate the orbital elements. Okay, so right now again, let me rewrite that equations. So by mu over AQ and times delta T. So right now for this one, we know the delta T is given 3600 seconds. So this one, right now this one is given. And we have our reference, so we pass in the perigee. So we can indicate the perigee at perigee. We can determine the E0. Okay. And we want to determine the true anomaly. So from here, the true anomaly can be related to, let me copy that equation again. So therefore here is this. We're using this equation to solve for E, and then when E is solved, we can determine the nu. So in this way, we solve the questions. Are we okay? So now numerically, is this. This again, this one we have to go to numerical approach, and then using whatever the program you implemented, or using whatever you learned from ES301. Okay, and so really to this point, it's very good for yourself and try to implement, try to hand out the programs. I'm going to use it. So here is a result. Let me list it. So n equal to 1, that's the first iteration is the E equal to 1.5705133. And when n equal to 2, and that's it, then my program stop at the second iteration. So from here, therefore, this is our E values. And that is in radian. So therefore, nu, using these equations, let me equation 1 equal to 2. So therefore, mu is equal to 1.9104 radian. And this one using equation 2. You good? Any questions about this? We'll look at the next one. Okay, so for this problem statement, we can put into the graph. So this is the orbit. So this is the focus here. So initially, we have the VP equal to 5 kilometer per second. And this is this time moment, so whatever, say t0. So now we want to determine what is the position R at time equal to 3 hours plus t0. So that means the traveling time from perigee to here is exactly 3 hours. And we want to determine what is R. Okay, so that's a problem statement for this. And this one is parabolic orbit. We still have to determine the orbital elements. So from here we see how can we do it. At least right now we know the E equal to 1. And I want to determine P, the parameters of these things. So probably I will try from here. Right now we only have a clue is this one. And how can we determine everything else? For example, what is this distance here? And we're still starting from here. How about that? So from our orbital equations, and h squared divided by mu and 1 plus e times cosine, this one. We're starting from here. And we think about what things we can utilize, and we know the E equal to 1, and we know the H is the magnitude of the angular momentum. Angular momentum, and here if this is RP, so we know the angular momentum at perigee is simply RP times VP. Good, at least we can relate to one of the given piece, VP. And what is RP? RP probably we can relate it is using the mechanical energy. So this one is this. This one equal to what is the mechanical energy of the parabolic orbit? 0. Equal to velocity squared minus mu over r. Okay, so in mechanical energy, we can relate velocity and positions, the distance. So from here, we can calculate the RP, basically equal to Q mu over V squared. Equal to 31888 kilometers. Okay, so we have RP, we have VP, so therefore H equal to 159,440. I think that's it. I don't even need this one. And what I'm doing, I will stop a little moment for collecting the needed information, and back to here for parabolic orbit. Let me write it up the Kepler's equations. For parabolic orbit, the Kepler equation is this. Let me continue. Okay, so we see from this equation, these are Kepler's equations for parabolic. So we see what things we need. At the beginning, we pick up the perigee as the reference point. So basically here, this trend will be 0. Because we pick up here. Okay, that is because we're starting from perigee. So the true anomaly here, the angle is 0. So that is 0. And now we say the 3 hours after passing the perigee. So that means here this one is 3 hours. And that one is simply equal to 108.00 seconds. So we know this value. And we know the gravity constant we can pick up from the textbook. So now we need P. We don't know P. Okay, so that is our scratching. So what is P? P equal to h squared divided by nu. And we already have the h, so we need a little bit more. So here is 63.776 kilometers. So from here we determine P. So there. So since we have everything here, okay. So therefore, again, for these equations, this, if you like, this is in our notation. This is our B. In terms of our notation, this is our B. I define this quantity as B. So maybe you can solve for B first, and then take the arctangent to get the information of the nu. Will be okay? So that kind of remind you of our symbols here. But anyhow, this one will be back to our first example. From here, we should be able to solve for this one quickly. So therefore, the B, by definitions, equal to tangent nu over 2. You can solve for is 0.7215 radian. So therefore, nu embedded is 1.25 radian. And that one, if you want to convert it, that is 71.62 degrees. Okay. So right now we have determined this angle here. That is 71.6 degrees. Then we can determine R. We simply use our orbital equation here. So therefore, the R, let me move to here. So therefore, R equal to P, 1 plus E cosine nu. And so here we have all the information. The P is given, and E is 1, and we know the nu. Either you are in radian or in degrees, okay, 1.25 radian. So from this equation, we can quickly calculate R. It will be 487 kilometers. So in this way, we get this one done. Again, from these examples I exercised with you is Starting from the beginning, I really don't know where I'm going. So I start with piece by piece. I collect the information I need. To the certain moment I feel good, then I back to here and to our original problems. And from that original problem, I look into what things are still missing. Then I go back to collect, continue. Then we do this one. Okay, so the calculus problems, if you kind of first time to exercise, you might have the feeling, oh, where I should start, and this is common. Okay, this is common, and the best way is first collect all the handouts, all the latest formulas with you, and begin to think and where to start, and then just kind of logically piece by piece going after. Okay. This is the last example. I don't know whether I can complete this today. If not, then I will repeat Monday. Compared to this one.